Welcome everybody. This is our second Patreon-only episode that we're doing. We're going to be diving into kind of the connections between these last two episodes that we've done on kind of these networks that we have in our brain and how those networks interact with each other. But then kind of more importantly, how that relates to all of the stuff that we talked about in terms of ADHD. We're going to really get into some personal stuff, some things about like how I deal with my ADHD, how I think about ADHD as a parent. And I think it's just going to be kind of a really lively discussion between the two of us, a little bit less structured than our other episodes, but really trying to tell you what came up for us that was really interesting as we did all this research.
Yeah. And I'll be drinking this water throughout, and so people know it's this 2-liter bottle. It's not soda. Okay. So it looks, I always think people are going to think I'm drinking a big giant bottle of soda throughout the thing. Welcome to The Social Brain. I'm Andrew.
And I'm Taylor. And this is a show where we dive into how the brain works. If you've ever wondered what's going on inside your mind, even the things that you're not even aware of, then this is the place where we can unpack that and really explore it.
Yeah, like Taylor mentioned, we're talking about ADHD and brain networks and stuff. And yeah, I mean, I feel like we really chose this topic because of you. because we're both super interested in it, and we got a lot of interest in the idea of ADHD. I remember getting a ton of comments, like especially even early on, like on videos we did about dopamine, or in videos, I did on my channel about dopamine. People really want to know like what's going on in the brain. And I think like something that was kind of surprising to me was when we first started looking into this, it was interesting to see like how young of a field it is in terms of like the neuroscience of ADHD.
And not even just how young it is, but how little kind of progress has been made in 30 or 40 years. I mean, neuroimaging was only created in the 1990s. So in terms of like actually looking at people's brains, like that's only happened in the last 30 years. And I think a lot of people really need to keep in mind too, when we're trying to talk about like what is different about the brain of someone with ADHD. First of all, we don't know clearly whether ADHD is like this one category thing. Like this is ADHD, right? There's subpopulations. It's a heterogeneous disease or disorder, which means that like there's different profiles of it that come out in different ways. And that makes studying the brain with this kind of stuff really hard. But the other thing is that when neuroimaging first came around in the 1990s, a lot of the researchers were doing studies with really small samples. Like they would have 30 children with ADHD and they'd put them in a scanner. And they'd have this result and it would come out and they would write up this thing and they would run with it. And as that work has progressed, we've realized that in order to really figure stuff out in terms of like what they call individual differences, what's different about ADHD than people without ADHD, you need thousands of people in these studies. And that's only been very recently that we've been starting to see that like all of those early studies are not replicating.
Yeah, that's super. I mean, and it makes sense. Obviously, like the sample size was pretty small. And then also just the fact that so much of it has been done on children. I mean, especially with ADHD, because, we think it has so much to do with cognitive control and with like the prefrontal cortex. And what's the least matured brain region in children? It's like the PFC. It's these regions. So, you'd think that there's going to be these difficulties at least translating from the data that was collected from, children, trying to translate that to adults. But it reminds me of like generally when we're talking about psychiatric conditions, especially like depression, major depression, it's the same story. I mean, we haven't done an episode on depression. Maybe we should, but I've done some research on it, and I had an episode where I talked about one model of depression. But it's one of those things where, yeah, it's clearly has to do with the individual, and our brains are so complicated. And I just think of it like you can have, a bunch of different patterns of changes in the brain that lead to really similar psychological outcomes. And it's like ADHD might be a category, like a psychological or psychiatric category. and same as depression. But does that mean that there's the underlying neurobiological causes are the same? It's like, probably not, almost certainly not, at least
Yeah.
in every case.
I think you're getting to this idea that I've seen come up a lot in like other work that we've done, where there's a common final pathway, where you might have different stuff that's going on in the brain that's contributing this, but then it ends up being expressed in a very similar way because it ends up at the end affecting some process, right? And that makes it really hard to study all of this stuff. And like the other thing that I didn't mention at all with neuroimaging and like studying this stuff in the brain is that a lot of the work was done on children, and anyone that does any type of MRI work with children, with healthy children, with children that don't have any type of categorical label, it's really hard because children move a lot, and in an MRI you have to be incredibly still to get a really good image of someone's brain. And now you put someone who has hyperactive type tendencies in a scanner, and their head's going to be all over the place while they're being scanned, right? And so I've actually seen studies where they had some kind of result that came out after studying this group of children with ADHD, but then when they corrected for motion and actually looked at, like, the stuff disappeared. And so this work is really, really hard to do, but after prefacing that, like, there still is some really cool insights that we've gleaned in terms of like where we think the work is going. So it's one of those things where it's like we can't take this stuff and run with it right now, but we can at least get some like insight into where we think this work is going and how it can maybe be helpful in terms of like turning that into a behavioral intervention.
Yeah, yeah, that's so true because I mean, there is like this the psychological research, the behavioral research seems like it is converging on like those two hypotheses that we talked about, the kind of like
Yeah.
cognitive control one and the delay aversion one. And there might be more to come, or expansions or modifications to those in the future. But I feel like that's a really good sign that we're starting to see like, okay, there's these sort of two I don't even know if you want to call them like causes, but ways to understand like ADHD, why it is the way it is. Does that make sense?
Yeah, and I think it might be important because I mean, people might have watched the episode, might not
Right.
have. Just to kind of preface a little bit what these two theories are, right? Because we have, on the one hand, this really strong prevailing theory that was kind of the first on the stage was this idea of executive dysfunction, which was this idea that like people with ADHD are not able to control themselves. They don't have like self-control, regulation abilities to stop impulses, right? When you think about fidgeting, when you think about hyperactivity, when you think about emotional outbursts, like all of these things that require some type of check that usually comes from the frontal cortex. And that's something that Andrew was kind of hinting at earlier, is that a lot of this work that's done with children are children that don't really have a fully functioning frontal cortex yet, right? But then the other kind of theory that we got into was this kind of really brave researcher that like went against the grain and was like, you know what, I have this other idea that's more of a functional perspective, that like a lot of the symptoms that we see for it from ADHD are actually them developing strategies to overcome this like internal restlessness that they have. And that was this idea of delay aversion that this guy Edmund Sanuga-Burke was thinking, like, maybe what's going on is that people with ADHD have this really strong aversion to delay, to being held back from the things that they want to do, from things that are just taking too long, right? Some of the examples I gave last time were like, you have these symptoms that are actually in the diagnostic criteria about like interrupting people, where it's just like, I can't wait anymore for my turn, right? Like this person's talking too slow and I have something important to say. But it's also like in the case of like sitting down to do a homework assignment or something, it's like in my brain, it's like, I have that video game that's really cool that like I'm on level 6. And I mean, there's not even levels on video games anymore. I'm dating myself, but something that's really important to that child, to that person with ADHD, that whatever they're doing right now, that delay is really, really uncomfortable. And that's something that resonates a lot with me as someone with ADHD. But what has kind of come out that's really interesting is they actually put these two theories head to head. And they said, which one is kind of explaining more? And they did all of these cognitive tests and all of these things. And what they found is that it actually is like subpopulations, that there are some people with ADHD that tend to have more executive dysfunction. They have a hard time controlling their impulses and their behaviors. And then there's this other group that is a lot more kind of characterized by this like inability to wait, this like,
Yeah, like, do you think now that I'm thinking about it a little bit more, I wonder if maybe I'm getting too like not focusing on the nuances enough, but it almost sometimes when I think about those two theories head to head, like I see that they're different, but I almost think like, is delay aversion a type of kind of lack of cognitive control in the sense that it almost is a kind of impulsivity? Like, I know there's probably nuanced differences there, but I wonder if what we're talking about is maybe different, this is speculation, but differences in specific cognitive control circuits that happen to, like, one happens to be really prominent and leads to the delay aversion sorts of explanations, and the other is just kind of a more general cognitive control deficit. Would that resonate with
no,
you at all?
I kind of see where you're going with that. One of the interesting things that they did in this research was really looking at how a lot of these people with ADHD, especially the ones that are in the subpopulation of like the delay stuff, like not like liking to wait, is that they were perfectly capable of exhibiting what would be called self-control in the way that we test it cognitively.
Right.
But it was entirely contingent on whether they wanted to be doing that task in the first place. Right.
Right.
And this is something that comes up with ADHD all the time, is that like there's this misconception that we just can't pay attention. Right. But really, we have this ability to hyper focus on things that we actually want to do and want to engage in. And so it was this idea that like it might not be that we can't control ourselves, but I get what you're saying, that in those moments where I have this kind of like delay kind of thing going on, that may be kind of overriding what should be controlling those impulses. And there's interesting research that's looking at like heightened amygdala activity for delay. So when you have someone with ADHD compared to a control that doesn't have ADHD, that when they have to sit there with something they don't want to sit there with, that the amygdala, which is usually about like threat or fear or whatever, I mean, some people
Stress,
don't like calling it fear, but stress, right? It's just like it feels uncomfortable. That could be sending these signals to these cognitive control areas that are just like, get me out of this, right? Figure out a way to like, let's be impulsive. Let's do something. And a lot of the impulsive symptoms under this kind of delay aversion idea really are strategies for making time go quicker. Right. So if I'm sitting there and I'm really bored and I hate that I'm having to wait for something, I'm going to start fidgeting. My leg is going to start bouncing. And if I focus on my leg, then all of a sudden I'm like, oh, time is going quicker. Right. I let my mind wander. And when my mind is wandering, time is going quicker. Right. I'm losing sense of time. And this is something that you see through tons of the research, is that people with ADHD have a really kind of different perception of time than controls do.
Yeah, that was really interesting. That's a really good point, that there's that. I mean, first of all, that control, I mean, that when you do that control and you look at ADHD subject children that can do these cognitive control tasks just fine, as long as they're motivated, almost like intrinsically motivated to do them, it almost starts looking like a kind of a motivation type of thing. Like on that, when you're looking at the delay aversion, like it's almost like an extreme expression of what is observed generally in like motivation research, which is that we're a lot more likely to, well, one way to think about this is you're less likely to procrastinate if you're intrinsically motivated to do something, right? That, like, everybody kind of understands that. Like, if you really enjoy doing something for its own sake, if you're into mountain biking or whatever it might be, you're not going to be like, oh, well, I'll do that later. Like that's, it's not that same sort of like what Andrew Huberman calls that limbic friction, where you're feeling like, I don't want to do this, but I'm going to go do it. It's of course like something you really want to do, so you don't get that urge to procrastinate as much. And I wonder if, like, if there's a sort of a motivation thing underlying it, which would make a lot of sense because, of course, the most common medication treatments for ADHD are dopamine agonists or drugs that increase the concentration of dopamine in the brain. And dopamine is so closely intertwined with sort of our motivation and our drive in our brain. So yeah, just kind of waxing philosophical about this, but it's
No, that
interesting.
actually plays in really well to some ideas that I've had just about the brain in general, but I think that are really heightened in this sense. So I study the self, like that. That's the work that I do. I look at like how the brain constructs a sense of self, how it is related to the things that we're motivated to do, and it's very tied to what you're kind of talking about, Andrew. This idea of intrinsic motivation. We did like entire episodes like a year ago on this idea of self-determination theory, like what are the things that we do just for the sake of wanting to do those things. And I feel like I'm really lucky that I found a passion, right? And that's allowed me to overcome a lot of my ADHD symptoms because I can funnel the things that I have to do into the things that I love to do, right? I can sit there and I can just listen to 15 hours of lectures on ADHD because I find it really interesting, right? But there's this divide here where a lot of parents with children with ADHD are having trouble with like the kids being really sucked in by like video games and all of these things. And if we go back to the work that we did on self-determination theory, I remember I think it was Richard Ryan or Edward
Yeah.
Deci was talking about how video games are so intrinsically motivating because they hit all of these different needs that we have. They're directly stimulating. They have this like social element of like playing with our friends and getting acceptance and recognition and like all of these things like all wrapped up together, and that becomes very self-rewarding, right? And sitting down and doing a math homework is not, right? And it ties into this idea of delay aversion, right? Sitting down to do a math homework, you're not going to see the benefit of knowing math for 10, 15 years, right? I'm still trying to figure out why I needed to know trig, right? And that's really hard for some of these children that like have this distortion of time where it's just like, yeah, you want me to do this thing that's going to give me some benefit in the future, but I want to do something that's going to give me benefit right now.
Yeah, and interesting. Like one of the things we talked about in the ADHD episode was the hyperactivity of the default mode network during sort of tasks that require kind of focused attention and reasoning, especially when you're not intrinsically motivated to do them, right?
Mhm.
This default mode network activity popping up when it shouldn't, meaning like, maybe you're thinking about other stuff, thinking about yourself, what's valuable to you, your past, your future, when you should be doing a math problem. And I bring that up because I just recently did this this episode about procrastination, and one of the recent findings on procrastination was that people who self-report higher levels of procrastination show a pattern of resting state brain activity where they have a reduced anti-correlation between the default mode network and the frontoparietal networks, and that meaning exactly that. So basically, exactly the same thing as what we were talking about with ADHD. And so there just this one sort of symptom that is common in ADHD, procrastination, but is also just a thing that people without ADHD sometimes do, is associated with that sort of similar pattern of brain activity. But yeah, anyway.
No, that's it ties in so well with what I was just getting at too, because like we've spent now 2 episodes talking about default mode network. Go back, watch them; they're great. But what the default mode is it's highly involved in mind wandering, right? And one of the core nodes, one of the core regions in the default mode network is the ventral medial prefrontal cortex, the kind of bottom middle part of our frontal lobe, which is the region that lights up whenever we're thinking about ourselves. And when I think about the default mode network, I think about it being very self-centered, it's very much a network in our brain that is trying to like solve self-relevant problems. It's like, think about what happens when you start mind
Hey, if you're watching this, then it means you are on the public version of this video. And if you want to see the rest of the episode, go to patreon.com/thesocialbrain and sign up for the premium tier. You'll get access to every single premium episode, every Patreon exclusive episode of The Social Brain, and you'll get the joy of supporting these guys. So yeah, thank you, and see you next time.